Okay, this is a recording for 7th hour on Thursday, May 5th. If you'll look at the sideboard, today you should be getting your half sheet for test notes. We'll be finishing our notes for 9-6 in class. You'll write your questions and summaries and glue in your graphs. And then you can work on homework 6. You might do an in-class assignment, some worksheets, or you might not this hour. And we'll just kind of see how things go. The announcement I have is that the quiz for 9-3 and 9-6 is on Friday, 5-6. And then I have in black here some announcements. Tomorrow there is a 4-point note handout check. You've done all those note handouts for this chapter, so I'll be checking those in class on Friday. Then also Friday is the quiz 9-3, 9-6. Monday morning is the chapter 9 help session, and so that's a little bit different because it's right after the weekend, but I have a teachers meeting on Tuesday morning. So Tuesday, the test chapter 9, and Tuesday also your chapter 9 notes are due. So if you remember, we talked about this on our last class, that on Thursday we would update our notes. So while you're writing this slide, 9-6 dilations and your essential question, can you draw dilations and draw dilations in the coordinate plane? Maybe when you write your level of understanding here, it's already a little higher than usual because we did go over a lot of these notes already, and that's just fine. Also, if you have time, put that in the table of contents. While you're doing all of that, you should get the half sheet of paper for test notes, half sheet for test notes. The teacher should hand those out to you as you're working on this slide. I'll ask that if you need more time, you pause the recording so that you can keep up, and I'm just going to tell you some more things. I will give you a few more moments to write this slide. If you need more time for this one, please pause this. Otherwise, I'm going to go on to the next slide that you need to be writing. This is your key terms page. And again, we had said on Thursday we would take time to do this since I wasn't going to be here. Everything that is underlined, you are going to write, and then just read those problem solving tip and the study tip. And again, I will read this to you to give you a little bit of time to write. If you need more time, then you'll want to pause this. So you're defining a dilation. A dilation or scaling is a similarity transformation that enlarges or reduces a figure proportionally. It has a center point and a scale factor. Just a reminder, we call that scale factor K. And so please write in there that the scale factor is K as you're looking at that. Then you'll also notice here that if K is greater than 1, the dilation is an enlargement, and we're familiar with that. And if 0 is less than K, which is less than 1, then the dilation is a reduction. So often that's a fraction that is less than 1, written as a fraction. If the dilation has a scale factor of 1, it's called an isometry dilation, and it produces an image that coincides with the pre-image, and the figures are congruent. Very seldom do we see this in our work. It is just something that I want you to know as you look at that. So again, if you need more time for the key terms, you can pause this recording. Otherwise, I'm going to go on to the next slide. We've already written about dilations from this one, and just another extra reminder now that you have your half sheet that any of those rules and symbols you should probably write on that half sheet at your leisure, not maybe right now. but just a reminder about that. I am going to go through the slides for this section just to remind you what we've already done. This was our example 1. We drew rays from the center through each point, and then we measured the distance from the center to each point. Then we found the distance from the center to the image by multiplying the original distance by the scale factor. If you need a calculator for that, I will leave some available, and the teacher in the room will give you that. And then you measure the new distance to find the image point, and then after you're all done, connect the image points. And so that's the problem that we had done in class together, and I'll go over 1 or 2 more like that. Then we did this problem, and just a reminder, as you're getting ready to do homework and having that quiz on Friday, that when we look at this, oh, there's a bell. When we look at this information that's right here, either of those can be used to give us the scale factor, the image length over the puppet length or original length, and the distance from a light to an image or the center to the image over the distance from the light to the original or the center to the original. So if we have the picture of the dilation, we can get the scale factor if we need that as well. Then we did this problem, and we talked about the fact that that blue shape that's graphed here is the original, and then in order to find the image, we use this rule. And we wrote the rule in symbols for this particular problem. And multiplying by 1/4 is the same as dividing by 4. Or you can take x times 1 and then divide by 4, and you'll get the same thing. We found that if e was -8,4, then e prime was -2,1. And then we were able to find all the rest of the points and plot those points as we went. The next thing I'd like to have you do as you go through these notes is take a few minutes, write your questions for this section 9-6, and write your summary. Just a reminder, your summary should be at least 3 sentences long, and it should include not "I know how to do this," but specifics on how to do this. Maybe some directions on how to draw a dilation, maybe telling what that rule is in the coordinate plane for a dilation. Take a few minutes and do that. Also, glue in the graph from this section. Glue in the graph, and please remember, don't glue in the big handout because that handout will be turned in tomorrow. Tomorrow I'll be checking all 4 of your section handouts from notes. The small handout that tells these rules and key terms, that also can be glued in your notes. If you want to pause this, if you're not ready to move on, the next thing I'm going to do is put up the homework handout. So if you need to pause this, go ahead. But here I'm going to move on to the homework handout. And when you're done with your questions and summaries and gluing things in, I'd like you to take some time and work on your homework. Just a reminder, before the bell rang during our last time together, we drew in these orange, and I would like to be drawing some things in here, but I'm having a little trouble with my SmartNote file. So I will just trace over here. We drew in these dashed lines that went from the center out through each point. So I have those in orange, and now I just drew over them in black. And then after we did that, let me see if I can kind of get rid of those. After we did that, then we measured from S, which is the center, to this point that's a vertex right here. And these aren't labeled, so that makes it a little hard. Since the scale factor is 3, we took 1.7 times 3, and then that will be where that point turns out right here. So this is the image point, which will be 5.1 if that was 1.7. So then you're going to measure the distance from there to there, multiply by 3 to find that image point for that one, multiply from there, or measure from there to there, multiply that distance times 3 to get your other image point, and then measure from here to here, multiply that by 3 to get your other image point. And mine aren't perfect, but then when you connect those, you'll know if things went well for you, because your image should look to have about the same shape as your original. And mine is fairly good there. On this one, next one, when you draw those lines out and use those, just a second. Oh, there's another bell. When you draw those lines out from here, you're going to go from S kind of through that vertex. These are getting smaller from S through that vertex, from S through that vertex, and from S through that vertex. And again, you'll go through that same process as before, but this time when you multiply times 1/3 or multiply times 1 and divide by 3, that will work also. Now you're going to measure the distance from here to here and then divide that by 3 or multiply times 1 and divide by 3 or multiply times 1/3. And so that is going to get to be smaller. So that image is going to be a little bit smaller. And so then you're measuring from the center to the vertex, then take 1/3 of that, center to the vertex, 1/3 of that, center to the vertex, and 1/3 of that. When you get down to number 14, notice that the center is actually way down here. So when you're drawing those rays, that first ray is actually just going to go through the side. This other one is going to go through the side, and then that one will go hopefully through that vertex as you look at that. So I'll draw those lines in as well so that you can see those as dashed lines on the smartboard. So let me find my tools for that and draw those in as dashed lines. So again, this will be one of those. Here will be the other one, and then that last one will go through that point there. Now, 7/4 is over 1, so it is going to be an enlargement. But once you measure this distance from there to there, you're going to take that distance and multiply by 7/4 or times by 7 and divide by 4. So take some time, finish that worksheet. You can work on homework after that. If you are in need of more work to do, the teacher will give you that in-class assignment. If you're doing an excellent job of using your time, then you can continue working on homework. And once you're done with the handout for this homework, let me slide this up to the top and I'll remind you, then you should be working on all of this. This handout on the back has graph paper, so you can put that 22 and 24 on that graph paper. There are extra books over in the front of my room. You know where those are, and you may use those if you would like to go through this. So use your time wisely, and I will be back tomorrow.